Hello and welcome to a video by Mr. Nagengast, which is dealing with the trigonometry of triangles. So it will be a blend of right triangle trig and law of sines and law of cosines. So let us go ahead and begin. For the triangles, determine the exact value for sine, cosine, and tangent. So I will do number 1 with you, and I will expect that you have 2 ready for class tomorrow. If we take a look at this, sine B, cosine B, and tangent B. So we have to make sure we're at the right angle. And in this case, not the right angle, but the angle that they're asking for. In this case, sine is opposite over hypotenuse. So my opposite is the radical 85 all over 11. And in this case, radical 85 does not reduce well, so we leave it as it is. Now the cosine of b is the adjacent over the hypotenuse, which is 6 over 11. And the tangent then would be the opposite over adjacent, and the opposite of b would be radical 85 all over the adjacent, which is 6. Now the sine of this A right here, now we're going to use black, that's the angle we want, is the opposite 6 over 11. Now notice that that one matches up with B. So the cosine of B and the sine of A match. Well, if that's true, we're going to expect that these two will also match. Well, what is the cosine of A? It is the adjacent, which is, in this case, radical 85 all over the hypotenuse, which is 11. And we see that holds true. Well, it does make sense because the opposite for A is 6 when the opposite of B is radical 85, which is the adjacent one for angle A. So it should, by this time, start making some sense for you. Now, tangent of A should be what we got for tangent of B, but flipped. It should give us a radical 6 over, a 6 over a radical 85, a 6 over radical 85. And if we look at that for A here, it is the opposite, which is 6 all over radical 85. So it does work for us. However, we need to acknowledge one fact here is that this needs to be rationalized. We don't want to leave something with radical 85 in the denominator. So by rationalizing, we'll take the radical 85 over radical 85. Remember, that gives us 1, so we're not changing the problem. And what we get with, or are left with, is 6 radical 85 all over 85. So once again, I would like you to do number 2. Now, the next part of this review says, determine if law of sines or cosines would best be used to start the problems in 13, let's say 13 through 10, and we're not going to solve any of these at this time. We've had some practice, and we'll see that in applications. Now, let's look at 3. We see that we have 2 sides and an angle. So we have a side, another side, and an angle. So we have some possibilities. Now, we need to recall that the law of sines will work for angle, angle, side, and angle, side, angle, or in other words, the side being sandwiched between the 2 angles. If we have a side, angle, side, where the angle is between 2 sides, then we're dealing with law of cosines. Well, in this case, they give us 2 sides, so we have to look for side, side, angle, or side, angle, side. If I draw a picture, and I usually draw one picture and use it for all my problems, it doesn't matter which way we draw this. It doesn't have to be proportionate or to scale. We just want to get an idea or remind ourselves that across from angle A is little a, across from B, if I'll call that the top angle, is little b, and across from capital C is little c, or side C. So that will help me as a reference for a couple of these. So in this case, I see that my angle A falls between both side C and side B. So what I really have is a side angle side. that tells me I will use law of cosines. Law of cosines. Now let's take a look at 4. If I look at 4, I see that I have 2 sides, 3 sides, but one of them needs to be labeled B. And if we look at this one, I will definitely have side, side, side. And again, you should be familiar with, that's law of cosines, which means that's the one we would start with to solve our missing angles. And remember, when you're looking at law of cosines and they give you 3 sides, you always start solving for C. So in this case, I'd use C squared equals A squared plus B squared minus 2AB cosine of C. The reason for that is because I'll get the obtuse angle opposite, if there is one, opposite the largest side. So I'd always start with that. Now if we take a look at 5, we see in this case we have 2 sides again and an angle. And if we refer to the above picture, we'll see that the angle is B that's given and the 2 sides are A and B. So once I'm given the side opposite that angle, I'm always going to get side-side angle. Now that tells me to use the law of sines. The last one, before I have you do the rest of them, is I'd like to look at number 8. And in number 8, you'll notice that we're given 3 angles. And I'm going to simply write can't determine. Now, why is it that I can't determine the side lengths? Well, the truth is I have an infinite amount of triangles that deal with these 3 angles. If I were to draw a picture of a triangle that might work for this, it'd be something like, maybe like that. It's not quite accurate. But you could see that I could have another triangle that's identical contained within it. And I would have numerous, or in fact infinite many, that could keep coming in there. I could also have larger ones. So there's no way I can determine the sides of those. So I'd like you to look at those questions. And now we're going to go ahead and look at some applications. In this application, I'm not going to tell you what kind of triangle it is. We're going to figure this out from our drawing. And usually it is best to draw a picture. It says 2 searchlights, east and west of one another, are located 3,020 yards apart on shore. So I've got a shoreline, and I've got an east searchlight, I'll call E, and we have one that's on the west shoreline, and it looks like there's a distance of 3,020 yards that separate the two. Now what else does it say? A ship out on the water is spotted between the 2 lights, and so it's somewhere out here, it's somewhere in the water, and it says that it is spotted between the 2 lights. The beam from the east one creates an angle between the ship and the west light of 38 degrees. So it sounds like going from the west and out this direction, 38 degrees, we're going to spot a ship. I don't know where that's going to be, so I just kind of elongate it. Then what it says is the other light, that must be the west side, spots the ship at an angle of 57 degrees from the ship to the east light. So roughly a 57 degree angle. Now again, I'm just approximating and writing these down as a sketch. I want to keep writing 37 for some reason. It's 57. And so I will find my ship in the crosshairs of those 2 lights. Now you'll notice that the first thing I see that would be easy to solve would be the angle S. I don't know if it's going to ask for that, so let's take a look at the question. It says find the distance the ship is from each light. So it wants this distance here, which is opposite my capital E, so I'll use a little e, and it would like the distance over here, which I'll call little w. And I am ready to begin with law of sines. I have an angle, I have a side, and I have an angle. So angle, side, angle, which is law of sines. But the problem, however, is what they want me to solve for. I can't because the distance they gave me is opposite the angle I don't know. However, if you're following along, you realize that's a pretty easy fix here. That we can simply find the measure of angle S by taking 180 degrees and subtract our two given angles. With that, I end up with a 85-degree angle found here. So I am ready to begin my law of sines. Let's solve for the west one. So let's solve for W. So I'm going to put my unknown in my equation in the top left because it works best for solving. What I put that over is my sine of 57 degrees, and that is going to be equal to 3,020 yards over my sine of 85 degrees. Now all I need to do is cross multiply and come up with an answer, and that's why it's nice to have that W there. After putting that into our calculator, we should come up with a value of approximately 254.5 yards away from the east searchlight. I leave it up to you, or sorry, the west searchlight. Wait, hang on, let's see here. I wanted to find the west side, so it's the east side. Okay, I leave it up to you to set up the other one. Just know that you'll want your east right there, or in this case, our little e. And go ahead and have that ready for me on tomorrow's class. Now, number 12 here, we see the sides of a triangular parking lot are 600, 328, and 410 respectively. Find the missing angles that form this lot. So it tells us that we have three sides. We're going to use law of cosines. So we need law of cosines here. Now, as I said earlier, we're going to solve for the largest side first. So we have 600 squared equals 328 squared plus 410 squared minus 2 times 328 times 410 cosine of, in this case, doesn't matter what we call it, cosine of A. So remember, cosine will allow us to find an obtuse angle. So I take the largest side, setting myself up to get the largest angle, and if it's obtuse, cosine is okay to do that when we do inverse cosine or arc cosine. That leaves me with the following information as I worked pieces of this, and this again is what I'm going to solve for. So I will subtract from my, I'm sorry, this is supposed to be 36. There we go, 360,000. Subtract 27, 5,684. And then we're going to divide. So I'm going to work this problem through, and you do that as well. So what I come up with then is 84,316 equals the negative 268,960 cosine A. The next step is to get a decimal by division, and that's an approximation there, cosine A. So once we do the inverse cosine, which can give us an obtuse angle, we'll get our answer, which gave me an angle of 71.73 degrees. So 71.73 degrees. Now to solve for the rest of the unknowns, I'll go to law of sines, giving me sine B equals 0.5191. Taking the inverse sine, I find out that sine B, I better use capital, sine B would give me then a value of 31.27 degrees. Finding C, simply subtract that from 180 degrees, leaving us with the following. Have a good night, and thank you.